The intent of this video is to help you understand how to solve a system of equations with two variables. This video is created as a companion to the Cramer's Rule app available on the App Store. Okay, this is a system of equations. It's got two equations, okay, and this video is going to help you understand what it means to solve a system like this. All right, I'm going to start with kind of going back a little bit. And let's take a look at this first equation. Now it says x plus y equals 10. And what that means is, okay, I've got two numbers, and if I add them together, I get 10. All right, so let's throw a couple of examples that makes that happen. So suppose that x was 2 and y is 8. Well, 2 and 8 is definitely 10. What about x equals 3 and y equals 7? Add those together and you get 10 there as well. What about 4 and 6? What about 5 and 5? Okay, I think you can agree we could be here all day picking numbers that would add up to be 10. And so far all I've picked is the integers. We've got all the fractions and decimals and all the numbers in between, right? Like 4.5 and 5.5, 4 and 1/3, 5 and 2/3. Right? And again, I could be here all day picking numbers that work, that add up to 10. So let's see what this means visually. I'm going to throw some dots on the screen here. That first one is x equals 1 and y equals 9. This is a combination that you add together and you get 10. There's another dot. X equals 3, y equals 7. 3 plus 7 is 10. What about 8 and 2? Yeah, x equals 8, y equals 2. That gives you 10 as well. I'm going to put one more dot. 5 and 5. 5 and 5 is definitely 10. Now again, I've been avoiding all the fractions and decimals and all the numbers in between. But if I sat here and labeled and named every dot in between, eventually you'd fill this thing in, you get a straight line out of it. Okay, that straight line, that represents every possible xy pair that when you add them together, you get 10. So that's a visual representation of all the possible solutions to that equation. All right, let's throw another equation up there. Here we have negative x plus y equals 2. And again, I'm going to throw some examples up here on the screen. So if x is 1 and y is 3, then equation 2 says negative 1 plus 3, well that gives you 2. There's another dot. X equals 3, y equals 5. If x is 3, then you have negative 3 plus 5, which is 2. There's another dot. 6 and 8, so we have negative 6 plus 8, and that gives us 2 as well. And again, all I'm doing is throwing up the integers. We have fractions, we have decimals, we got all the dots in between those. Throw them all up on the screen. Eventually you'd fill that in and you'd get a straight line out of it. Okay, so that blue line, that represents every possible xy pair that fits in equation 2 and makes it work. The green line was equation 1. It was every possible xy pair that makes equation 1 work. Check out that one dot in between. We have an intersection point. We've got one dot there that happens to be on the blue line and the green line at the same time. So that one intersection point happens to work for equation 1 and it works for equation 2 at the same time. The location of that dot is x equals 4 and y equals 6. All right, so if you plug x equals 4 and y equals 6 into that first equation, 4 plus 6 is 10. X equals 4, y equals 6 into the second equation, you get negative 4 plus 6, which is 2. So that one spot works for both equations at the same time. Okay, this is called the solution to the system. What we're looking for visually, what we're looking for is the intersection point between those two lines. It is the one xy coordinate that is the same on both lines. When we solve a system of equations, we're basically looking for the intersection point between those two lines. All right, so let's see how to do this. There's several ways to come about the solution. Okay, you can use substitution method, you can use the elimination method. The method that we're going to describe here is called Cramer's rule. To use Cramer's rule, we're going to set up a couple of determinants that we need to calculate values for. Okay. If you need a reminder on how to calculate determinants, please visit our website at www.reimarapplications.com. Okay, our first determinant here is D. We're going to call it D. The way we construct this determinant is we grab the coefficients in front of the x, the -2 and the 3, and we grab the coefficients in front of the y, which is 1 and 1. Okay, so that D determinant is created by grabbing the coefficients in front of the x's and the y's. We have another one, we're going to call it dx. Now dx is created by taking the x column where those x numbers were, and we're going to replace it with the constants, the -1 and the 9. So we're swapping out the x column. The y column stays unchanged. We've got the two 1's there from the y's, we keep those in place. Now we need a dy determinant. With the dy determinant, I put the -2 and the 3 back. Okay, we put the original numbers back. This time I'm swapping the y column out with the constants, the -1 and the 9. All right, now we've got our three determinants. We're going to evaluate these three. The way we evaluate it, -2 times 1 minus 3 times 1 gives us -5. For the dx determinant, we have -1 times 1 minus 9 times 1, and that gives us -10. And for dy, -2 times 9 minus 3 times -1, so we have -18 plus 3, -15. All right, all of that leads us to how to get our x and our y. To get the x value, we'll take our dx results, we'll divide by the d results. So this is -10 over -5, which is 2. Okay, so far we have 2 for x. Now we need the y variable. To find the y, we take our dy determinant and divide by the d determinant, which is -15 over -5, and the results there are 3. All right, so let's go back and take a look. So the solution to this system is x equals 2, y equals 3. It is the intersection point between those two lines. The green and the blue represent graphs of those lines, and the circled point there is x equals 2, y equals 3. It is the intersection. This is the solution to that system of equations. Okay, we're not going to get off that easy. We got a special case that we've got to worry about. In your efforts to solve this thing, if you generated 0 for the d determinant, then we've got issues here. You cannot divide by 0. Division by 0 is undefined. Here's a case where this could happen. I got 2x plus 3y equals 4, 4x plus 6y equals 8. If I try to calculate a d determinant, fill in the 2, 4 where the x's are, the 3, 6 for the y's, you end up with 12 minus 12, which is 0. Now I can't divide by 0, so I'm kind of stuck. All right, so what does all this mean? Remember what we're doing here. When we solve a system of equations, we're looking for an intersection point between the two lines. When Cramer's rule gives you d equal to 0, basically it's saying we either have no solution at all, or we've got an infinite number of solutions. Let's take a look and see what that means graphically. For the case of no solutions, the two equations that you have describe lines that happen to be parallel to each other. Parallel lines never intersect. They never touch each other. They run side by side infinitely in both directions. If they never intersect, there is no solution. And we have the other case for infinite solutions. What this means is the two equations that you have actually describe exactly the same line. They may look like two different equations, but they're really describing the same line. So that says that every xy pair fits both of them because they are the same line. This is the case for infinite number of solutions. All right, so then what do? What do I have? Is it all or is it nothing? All right, so there's a quick check we can do here. If you get d equals 0 for determinant, what we can do to figure out what we've got is we'll set up a couple of quick ratios. The 2 over 4 comes from the x coefficients, so we'll write that down. The 3 over 6 comes from the y's, and then the 4 over 8 comes from the constants. All right, let's take a look at these three. If I reduced each of these fractions, they all reduce down to 1/2. Okay, if you end up where all three of those ratios give you exactly the same value, this is telling you that you have an infinite number of solutions. All right, if you take a look just real quick, that top equation, 2x plus 3y equals 4. If you multiply both sides of those equations by 2, that 2x becomes 4x, that 3y becomes 6y, and that 4 becomes 8. That's exactly the second equation that you have. All right, so what you thought was two separate equations, it's really the same equation. In other words, it's the same line. This is an infinite number of solutions because it's exactly the same line. If any one of those is different, right, they all three have to be exactly the same. If any one of them is different, then you've got the case of no solutions. This video was created as a companion to Cramer's Rule app, which is available on the App Store. This app will help you solve systems of equations in 2 or 3 variables. It doesn't just give you the answer, it also provides all the details that went into the calculations. So if you're working with some homework problems, you can see exactly where your mistakes are, and it can help you figure out what's going on. For additional videos, please visit our website at www.rymarapplications.com.